CAD, or computer-aided design, is a tool used by engineers and designers to bring their ideas to life. CAD is used to model and engineer designs, allowing engineers to visualize, test fit, and explore how mechanisms function before prototyping or manufacturing. CAD provides users with an efficient and robust engineering environment to test, design, and implement their ideas. It is used in a vast variety of fields and industries, including automotive, aerospace, architectural design, product design, machine design, and several others. Designing in a CAD system enables engineers and designers to iterate on designs quickly and inexpensively. CAD models can be reviewed, analyzed, and updated, ensuring the design is operational and safe before beginning the prototyping and manufacturing stages. CAD saves resources and cost by reducing errors, miscalculations, and time to market. To better appreciate the advancement of CAD, it's important to look back at how the design process has evolved. The history of CAD is a fascinating story, spanning a nearly 60-year-long timeline and incorporating multiple technological and platform shifts. For a full and excellent narrative, please feel free to browse cadhistory.net. The nutshell version is a story that steps from a completely manual process using drafting boards through some of the earliest software work in relational geometry from people like Ross, Cohen, Sutherland, all the way through to today's distributed software as a service platforms. The early work on hardware and software was largely academic until the mid-60s, when, for the first time, the availability of commercial mainframes in the deep pockets of the largest corporations, such as GM, General Dynamics, and others, enabled the application of these technologies to commercial and military purposes. These systems were expensive and primitive by today's standards, largely duplicating the wireframe manual drafting process, and ran on proprietary hardware, but it was a start. By the 1980s, we had the next platform shift, the personal computer and the x86 instruction set chips from Intel. With office computers and the arrival of a certain company, Marin Software Partners, that later became Autodesk, affordable computer-based drafting in 2D became available. In parallel to this migration to the personal computer, another startup successfully married the emerging technology of solid geometry kernels to the Unix desktop workstation. Much of the research was done at Cambridge University, UK, and commercialized by a number of prior companies, including Matra Data Vision, Euclid, and others. The Unix desktop workstation could handle a significantly greater computational workload. The startup in question incorporated in May 1985 as Parametric Technology Corporation, or PTC. And while not the first solid modeler, it did introduce the concept of parametric features, or the formulaic sequential regeneration of a model. The next platform shift was capitalized on by the 1993 incorporation of Winchester Design Systems that later became SolidWorks, and the 1994 commercial release of a product by the same name. This time, the new platform was a standardized interface of the MS Windows operating system and UI development tools that worked across x86 hardware platforms. SolidWorks was also the first large-scale commercial CAD application that made heavy use of off-the-shelf technologies for core capabilities. Parasolid for the kernel functions, and D-Cubed for 2D and 3D constraint solvers. 3D parametric feature-based CAD has become the standard for manufacturing and design companies. As companies rely more and more on these systems to innovate and design, more and more data is generated. To keep all the files protected and revision managed, companies invest in product data management, or PDM, and product lifecycle management, or PLM systems. These systems protect data in a vault, require a check-in, check-out process, and revision manage the designs. They allow companies to track a design from conception through the engineering process, and in the case of lifecycle management, to the end of its life. In large companies, intricate IT networks are installed by CAD administrators to achieve the level of data integrity needed. Manufacturing has become globalized, and the supply chain has significantly expanded. Intellectual property from the CAD system is needed by vendors, suppliers, or shops to manufacture designs. No longer is every aspect of a design manufactured or created in-house. Files have to be emailed and copies of data are made, creating a data disaster. Engineers have trouble understanding which file is the latest revision of the design, which one was sent to the supplier, and left wondering about the security of their data. Many companies operate in this stage today. Following a long stagnation and platform evolution, the explosion of cloud, web, and mobile that grew exponentially since 2005, software as a service and the social web have become the new standard for business-to-business and business-to-consumer interactions. Think about this. When SolidWorks was launched, none of these companies existed. Google, PayPal, Facebook, Amazon Web Services, Salesforce, Snapchat, Uber, or Twitter. The power and accessibility of this new platform, harnessing the cloud, along with its inherent collaborative capabilities, was a huge draw for luminaries like Hirschtick, McElhenney, Harris, Lee, Lauer, and Corcoran to build a new CAD offering. Incorporating as Belmont Technologies, later Onshape in 2013, and entering full commercial release in 2015, Onshape capitalized on scalable cloud computing, the advanced data security offered by AWS, and a zero IT footprint to offer a compelling alternative to aging desktop software. With frequent releases and a completely fileless database architecture, today Onshape stands alone as a full cloud professional-grade 3D design and data management platform. The invention of CAD revolutionized the way engineers work and continues to evolve with the power of cloud-based computing, as demonstrated by companies pushing the forefront of technology, like Onshape.